So section 10.4 talks about parabolas, and there's a lot of things that I want you to be able to find for parabolas. Of course, the most important one is the vertex. So let's take a look at the vertex here. Now, what I would suggest in terms of finding the vertex is you start by looking at what makes the squared term equal to 0. So in this case, what value of x makes the squared term equal to 0? A 2. And if I put in a 2 here, if I did f of 2, this would be 0, times 3 would still be 0, and then I'd end up with minus 1. So 2 and minus 1, that's your vertex. Now we've already got that graphed on Desmos, and the nice thing about Desmos, let's try this one up here. The nice thing about Desmos is that you can actually see the vertex. You can click on it. 2, negative 1. So great. Now, I've structured things here so that I can change the value of a. The value of a, if I increase it, makes it narrower. If I decrease it to between 0 and 1, it gets very, very wide. And then for negative values, it opens down. So, in any case, our value is stuck here at 3. Let me put that back here. Let's see if we can't determine a few other things about this parabola. Some of the things that I could ask you would be for the x and y intercepts. So the y-intercept is pretty easy. Right there. There's your y-intercept. Now, in general, how do you get the y-intercept? Well, you plug in something for x. What are you going to plug in for x? Anyone out there? What do I plug in to find the y-intercept? 0. Well done. So if I put in a 0 here and a 0 here, f of 0 would be 3 times negative 2 squared minus 1, which is 3 times 4 minus 1, or 11. So you don't necessarily have to go through all that, especially if you've got a nice program like Desmos. It's pretty easy. It's right there. Now, that's your y-intercept. So y-intercept. What about the x-intercept? So for the y-intercept, I set x equal to 0. What do I do for the x-intercept to find that, or intercepts? Well, plug in a 0 for y. So that'd be a little bit of a mess. It's, f of x is effectively my y. So it's going to be 0 equals 3 times x minus 2 squared minus 1. Now, I'm going to use the square root property to find this. I'll move the 1 to the other side. It's going to change signs when it changes sides. Divide by 3. And here we're going to use the square root property. So it's going to be square root here, square root there. But there's something that a lot of people forget, and that is there's a plus or minus here on the left-hand side. So I get plus or minus the square root of 1/3 equals x minus 2. I'm going to take and move that 2 to the other side. 2 plus or minus the square root of 1/3 equals x. Now, these values you can get from your calculator, or you can get them from Desmos. You can get them from Desmos in a couple ways. Let me show you the exact way, and you might want to keep this one around just in case Desmos doesn't round to enough digits for you. So we'll do 2 plus, and then the easy way to get the square root is SQRT, square root of 1 divided by 3. Oops, 3. There you go. So about 2.5773. If you want the negative value, there you go. And let's just double check both of these. Oh, down here. That's looking better. So about 1.432, perfect, or 423, and 2.577. Nice. So those are your x and y intercepts. Now there's one last feature that you could be asked about in terms of a graph like this. Notice that this graph is symmetric. right? To the left and to the right of this point, x equals 2, y equals -1, the vertex, it's a mirror image of itself. So it's symmetric around this line, x equals 2. It's a mirror image of itself around that line. So nice. That's the axis of symmetry. So those are the things that I could ask for on an exam. And there's nothing wrong with double checking your work on Desmos. I still would probably want to see some of the work, but there's nothing wrong with making sure that you got it right before you hand that in. So how are we looking on this first one? All right, let's try a couple more. Example B says find the x and y intercepts of the graph of the quadratic function. So again, that's programmed in Desmos. That's pretty much already done for us though. So let me shut these graphs off. I mean, if you do this in Desmos, the hardest part for you is going to be to get this thing completely in view. And so what you can do is you can hit the minus key to zoom out a little bit, and then just click here and here and here and here. Wow. There's all your work. So you've got it as the x-intercepts are at -5 and 7. The y-intercept is at -35. The vertex is at 1 and -36. So, wow. Now, there is maybe one more thing that I'll ask of you on this one, but let me just show you that you could actually confirm some of this stuff and you can actually prove some of this stuff to yourself. So, this is example B. F of x equals x squared minus 2x minus 35. So, for instance, if I wanted to find the y-intercept, I would set x equal to 0. So that means putting in a 0 here, and a 0 here, and a 0 here. Now these just disappear, and all you're left with is that minus 35. So that's one of your points, 0, -35. What about the x-intercepts? Well, as Joe helped us out on the last one, you're going to set y equal to 0, so that's going to be 0 equals x squared minus 2x minus 35. I hope you don't pull out the quadratic formula on this one. That's just going to be x minus 7 times x plus 5. And from that, you can see the two solutions, x equals 7 and x equals -5. Beautiful. Let's see, what else do we need to find? We've got the vertex. So let's see if we can't write it in a different form. Now, one of the different forms you could write your parabola in is f of x equals a times x minus h squared plus k. And h and k are your vertex. So vertex at h and k. Now that a here is really the same as this here, right here. That's your a. That's the coefficient of your x squared term. And I know the vertex. So what's the vertex? Let's go back. It was 1, -36. So, okay, vertex is 1, -36, and a equals 1. So let me just write those things down. That means I can rewrite this as x minus 1 squared plus -36. And there's a 1 here. Let me just kind of help choreograph where some of these things come from. The a equals 1 comes from the coefficient of x squared. H, right here, goes in there. And then I've got a k. And that's my k. So, nice. Basically, once you know the vertex, you can easily put it in this form. And it's handy to have it in that form. This is a process called completing the square. Now sometimes a book might write it just like this, as x minus 1 squared minus 36. And that's fine. So we're going to do that one again. But notice we got several things out of this. We got the vertex, which was 1, negative 36. We've got the Y-intercept, 0, negative 35. The X-intercepts, we're at 7 and 0 and negative 5 and 0. The one last thing I could ask you for is the axis of symmetry. And again, you can see that. So let's take a look here. It's just going to be the equation x equals something that goes right through this point. And that equation is going to be x equals 1. So let's put a 1 in here and just turn that graph on. There's your axis of symmetry. That's nice. If you were drawing this by hand, it also gives you extra points you can draw. For instance, this point here is 1 unit away from the axis of symmetry. That means there has to be another point 1 unit away on the other side of this. And there you go. If I dial it in right, there it is. 2, negative 35. They're symmetric points. That's an extra credit point if you can help me out by drawing that point. Okay. Let's finish this up with this one right here. So I'm going to kind of skip down to example D, second one in example D, because this one's got something kind of interesting going on. Let me shut off this one here. And there we go. What's interesting or unusual about this one? Can anyone see? How many X-intercepts does it have? How many times does it cross the X-axis? Yeah, just the once. So that's a little unusual. I mean, if you take a look at some of our other examples, like the one we just dealt with, that had 2 X-intercepts. But this one just sits on the X-axis. It touches it once. So it only has 1 X-intercept and 1 Y-intercept. That's okay. We can still work with this problem. It's just a little bit different. So let's see here. We'll start by finding the Y-intercept. So this is example D. F of x is x squared, 4x squared minus 12x plus 9. So f of 0 would be 9. If I wanted to find the x-intercepts, that's a little bit more challenging, especially for a problem like this. 0 equals 4x squared minus 12x plus 9. But this one's a little bit unusual. And if you played with it a little bit, you could see that it factors into, actually I blew that one, 2x minus 3 times 2x minus 3. In other words, this factors as 2x minus 3 squared. It's a perfect square. And the reason I was in tune to look for that is because I noticed the end terms were both squares. And if the middle term lines up, then it's a nice perfect square. This one is. Now it only really has one solution, right? It's when 2x minus 3 equals 0, or 2x equals 3, or x equals 3 halves. Now that 3 halves is going to do a lot for us. It's going to be the x-intercept, because when I put that in, I get y equals 0. So 3 halves and 0. But it also has another extra special function, and that is it's the vertex. If you look at the graph, it's the vertex right there. And you don't have to rely on Desmos for all this stuff. There's actually an equation that helps you find the vertex. So the vertex of f of x equals ax squared plus bx plus c is x equals negative b over 2a. Which, you know, looks kind of strange and suspicious, but you can actually prove that in a bunch of different ways. The easiest way is with calculus, but you can also do it by completing the square. I'm not going to prove it here. But let's just look back at f of x equals 4x squared minus 12x plus 9. So b is going to be negative 12, and a is 4. So I get 12 over 8, which is 3/2. So x equals 3/2 is the vertex. It's also your axis of symmetry. And if you went back and checked it with other equations, it would also work out like this one right here. So x squared minus 2x minus 35. If I wanted to find the equation of the axis of symmetry, it's negative of b, which is negative 2, over 2 times 1. So 2 over 2 gives me x equals 1. Nice. And that's what we came up with earlier. That was your axis of symmetry. Okay. That's a nice little formula. You might want to circle it, put it someplace special in your notes so that you don't forget it. But are there any questions? Are you looking good for some of the stuff here? Now, I'm more than happy for you to use Desmos, but you should still be able to do things on the exam like factor and solve or plug in 0, etc. I still am going to want to see some work, but I have no problem with you checking your work on Desmos. All right, good luck.